This is a really good case study from Encapsula that occurred in 2013. And it's interesting for a few different reasons. And one of them is expressed here in the quote, a DDoS event that went on for weeks. Think about the number of resources a persistent attack that lasts for weeks would consume on the target. I don't just mean physical resources, but human resources, all tied up trying to fight this. Let's have a look at how it worked. The attack started off as a SYN flood attack of 30 gigabits. Thinking back to the previous module about the scale of DDoS attacks as of early 2016, this may not seem particularly big, but 30 gigabits is still a reasonably serious attack, particularly in 2013. However, it wasn't amplified at all, it was just a straight out SYN flood attack. However, that was consequently followed by an HTTP flood attack of 10 million requests per second, and they were all targeting a very resource-heavy page. Now, the interesting thing here is the way the different styles of attack were chained together. Just as you're busy fighting off a SYN flood attack, in comes the HTTP flood attack. Now, the thing about the HTTP flood attack as well is it was targeting an API, not a typical web page. And the reason that's significant is that there are defenses which can help defend a web page, such as by using JavaScript challenges, which are difficult to implement in an API. An API is a very autonomous resource, which humans normally don't interact with directly, not like a web page. As Encapsula was fighting off these attacks and implementing new defenses, the attackers were adapting, and they added new bots that could construct more organic requests. So they were doing things like persisting cookies between the requests. And adding cookies is one way that defenders tend to use to try and keep out malicious traffic. We'll talk more about that in the final module of the course. Now, during this attack, Encapsula noticed a message from someone. Now, this was directed at the Encapsula client, the one who was being subjected to the DOS attack. And the interesting thing here is that this individual's machine was actually part of the botnet launching the attack. And what they'd noticed is Internet Explorer opening up all of these windows, all of them loading the target website. That actually tells you quite a bit about how the attack was working. The botnet was causing the infected machines to fire up Internet Explorer and load the website. And of course, if you could do that with enough infected machines, make enough requests, particularly if it's 20 different windows of the browser all at once, then that is going to greatly increase the load on the target site. Now, as it turns out, the bot was meant to open those windows transparently, so that the individual that was part of the botnet wasn't aware of the behavior, certainly not overtly aware. They wouldn't see a window popping up. Over time, Encapsula eventually identified that this was a botnet known as Cutwhale. You'll also see it called Pushdo at times. And once they actually understood what that underlying botnet was, they were able to implement appropriate defenses. Encapsula doesn't talk specifically about what those defenses were. And in fact, you'll find that most organizations that do any sort of denial of service defense don't like to talk too much about details, because they don't want the attackers to learn what the patterns are that they're looking for, because that might help them evade them. So this was just a really good example of how a DOS can be quite a sophisticated attack made up of many different components using various DDoS approaches. And I hope that this one and the previous GitHub example give you a good sense of just how malicious and how intense these attacks can be. That's the last thing I wanted to talk about in this module. Let's go and take a look at the summary.